this computer. Okay, so let me see. I heard the sound. Okay, so that noise was nothing. Now they said a hockey traveling. Let's do this question. Once after doing this question, we'll do some question bank questions also. Okay. So a hockey ball is traveling horizontally with a momentum of 0.8 kg meter per second. So it has a momentum. This is the momentum. Okay, 0.8 kg meter per second. Just before it hits the goalkeeper's leg pad. Okay, fine. It rebounds horizontally from the leg pad with a momentum of minus 1.2. So this is the momentum of minus. This is the final momentum of it. It is initial momentum. It is final, but your momentum is in opposite direction. Okay, the graph shows, this is for the hockey ball. The graph shows the variation in the momentum of the ball during the process. Okay, all of you, everybody understood this situation, what's happening here, na? You guys know hockey player jade take odar ke ekta kneecap de. Tumra jano the hockey player, hockey dekho to na? Okay, jano ball ta otoba that disc, if you're talking about ice hockey. Is it ice hockey? No, hockey ball it is. Okay, so jano knee moddhe na lage moton. So that ball hit the knee pad, and the momentum for this knee pad is this direction. This was the initial momentum, and this is the key final momentum. Initial momentum was 0.8, and final momentum is minus 1.2. Minus, so left dike ami minus nichi. ঠিক আছে? So this is the change in momentum. এটা হচ্ছে initial আর এটা হচ্ছে final. Initial এটা হচ্ছে কি final. Now, then the first question, describe how the ball momentum changes over time from 0 to 10 milliseconds. So over time, what happens to the momentum from 0 to 10 milliseconds? Acha. You know, from 0 to 4 milliseconds, if I'm not wrong, from 0 to 4 milliseconds, what's happening over here? It is, the momentum is constant. So at 4 milliseconds, it's hit the pad, na? That knee pad. Okay, so the momentum decreased. Okay, the moment decreased. Okay, you have to find here the gradient. What do you have to do? Find the gradient. You need to know how much momentum is it changing per second or per minute. Okay, per second or per minute or millisecond. এখানে millisecond এ দেওয়া আছে না? Okay, per second এ কত momentum change হচ্ছে তোমাদেরকে এটা কি করতে হবে? Gradient find করতে হবে. So let's find the gradient of that then. So gradient find করার জন্য এখানে momentum kg meter per second. এটা কত? এটা হবে 4, 0.8. Okay, আর এটা কত? This is 8 না? এটা হবে 8, minus 1.2. So তোমরা y2 minus y1 divided by x2 minus x1 করে gradient find করো. So gradient equals to, okay, y2 minus y1. So minus 1.2 minus y1. y2 minus y1 divided by x2 minus x1. x2 কত? 8 minus 4. But 8 minus 4k into 10 to the power minus 3 করতে হবে আমাকে। কেন? এটা মিলিসেকেন্ডে দেওয়া। তো সেকেন্ডে কনভার্ট করতে হবে। Do this in your calculator, check how much is the value you guys are getting. Put this in your calculator, I'll pause the recording. আচ্ছা। आंसर কত পাচ্ছ? minus 500. Minus 500? Minus 500 কি?
kg, no, kilometer.
Minus 500, na? You're getting minus 500. Okay, so that means the momentum is changing minus 500 kg meter per second every key second in mudde. Are you sure about this? Let me just check the mark scheme for this. I mean, it's too much value, na? The way it is changing. Minus 5 into 10 raised to minus 4. You gave 10 to the power minus 3 over here. You did minus 3 this up. Minus 1.2 minus 0.8 divided by, can I see? 8 minus 4 into 10 raised to minus 3. Show me yours. What did you do? I'll pause the recording. So resume. So they said minus 0.5 kg meter per second per millisecond. In my case, what did I do? I convert it to meter per second. Meter per second every second. Mane 500 change হচ্ছে তোমাদেরকে এটা বলতে হবে। Okay? 3 মার্কের জন্য। After that, what happens? After that, at 8 seconds, what happens? 8 seconds, the momentum changes to key minus 1.2. From 0.8 to 1.2. In between, how much second did they take? They took 4 seconds. And what rate did it change? It changed the rate of, according to us, minus 500 kg meter per second every second. Or if you want to write like them, it will be 10 to the power 3, minus 3. If you don't give this 10 to the power minus 3, it will be minus 5 kg meter per second per millisecond. ठीक है sir? Okay then let's see what they wrote over here. Yeah, so momentum is initially 0.8 for the first, and over period of 4 to 8 milliseconds it changes uniformly. But okay, momentum is then constant at minus 1.2, okay, away from the goalkeeper for the remaining 2 milliseconds. সবাই বুঝছে কিভাবে describe করছে এখানে? So from now on, if they tell you to describe the momentum from the graph, don't forget to see the key gradient. Don't forget to find the gradient. Everyone online, is it clear? Everyone?
Answer.
Okay, understood.
Yes.
Fine then. Let's continue now. Then they said, explain in terms of Newton's law why the momentum changes from positive to negative during the ball's collision with the leg pad. Okay. Initial momentum of the leg pad was key 0. The ball had a momentum of 0.8. Okay, so initial momentum is 0.8 minus 0.8. Okay, sorry, 0.8, my bad. Okay, the final momentum. Okay, if now the leg pad is also moving now. Okay, Newton's third law key. There are two bodies. Every action has equal and opposite this thing. After hitting, there is a force on both the bodies, but in opposite direction. Okay, so the momentum needs to be conserved as well, no? Momentum needs to be conserved. So the momentum is in opposite direction. Okay. Newton's third law key. Duta body kotha bolte hobe. Forces in opposite direction bolte hobe. After hitting. Okay, with the same magnitude. Or marks ki mein ki likhchi. The leg pad provides the resultant force on the ball, which will change the momentum according to Newton's second law. Did this is second law or third law here? Newton law. Okay. The leg pad provides the resultant force on the ball. Basically, the ball hits the leg pad. There is a force equal and opposite force on due to Newton's third law, and due to Newton's second law, there is a resultant force. Newton's third law diye ki hobe? Equal and opposite force on both the bodies. And Newton's third law. Newton's second law diye ki hobe? There is a resultant force on the ball. Okay, I'm pausing the recording. Write it down. Yes. What is the resultant force on the ball during the following period? 0 to 4. If you check 0 to 4, the momentum is not changing only. If the momentum does not change, that means there is no resultant force acting. So you have to say the resultant force from 0 to 4 is what? 0 Newton. Okay, now 4 to 8 milliseconds. Fine. 4 to 8 milliseconds, yes, it is changing. Like 4, এটা হচ্ছে তোমার 4. Yeah, this is 4 milliseconds, and this is what? 8 milliseconds. 4 to 8 milliseconds, there is a change in momentum. Okay, so what was the change in momentum we got? We got the gradient, na? Okay, that is the, I think that is the force, if I'm not wrong, because I'm doing what? Momentum and time. Mv minus mu divided by t is what? Force only, na? Yeah, so that is the force acting over there. Keep I think I'll go with minus 500. That is the force, because I'm second day convert করছি ওটাকে কিছুক্ষণ আগে আমরা gradient পাইছি না, we got the gradient না, what was it we got? Minus 500 না, that is a force actually. The gradient of momentum time graph is force. Why? Force এর formula কি? Force এর formula কি? Force এর formula হচ্ছে অনলাইন সবাই কি বুঝতেছে আমি কি বলতেছি এখানে? Force এর formula হচ্ছে mass divided by t. Don't you think this is gradient? This is gradient, right? One divided by the other. That is the gradient. আমরা উপরে gradient কত পাইছি? 500 minus 500. That means the force on the ball is minus 500. Clear? Okay. So now what is this thing? Actually, let me check the marks. 0, 500. Then last is also 0, because 8 to 12 seconds. If you notice 8 to 12 seconds, what's happening? Nothing. There is no change in momentum. If there is no change in momentum, there is no resultant force acting on it. Fine, everyone, fine with this? No. Now, they said draw a new version of the graph for a collision in which ball is initially traveling at half the speed. Okay, so আগে কত স্পিডে যাচ্ছিল ওটা আমার জানার দরকার নেই। তোমার স্পিড যদি কমে যায়, তোমার মোমেন্টাম আধা হয়ে যাবে না? If your speed is half, your momentum wait, somebody messaged me. Aska. Okay, so now draw a new version of the graph. Okay, so half the speed, that means your momentum. Before your momentum was what? 0.8. Now your momentum will become 0.4. Find that 0.8, and for the impact time is also half. So okay, impact time কত নিছে 0.8 to 0.8 এখন 0.8 to sorry from 4 seconds to 8 seconds. So now it will be 4 seconds to 6 seconds. তোমার impact time কমে গেছে. So this is your new graph. Okay, here they got, sorry, not here, they impacted over here. Okay, and it got completed. এখানে 8 সেকেন্ডে কমপ্লিট হয়েছে না, এখন এটা কত 6 সেকেন্ডে কমপ্লিট হয়ে যাবে, কিন্তু আমার ফাইনাল মোমেন্টাম কত? My time has been halved, but what is my final momentum? Do I know that? Did they give me that? Let me see.
Speed is half.
Speed is halved, so momentum is also halved. Ball and mass the same. The mass of the ball is constant, but your speed is halved, therefore your overall momentum of the ball is also halved, for which the impact time is also halved, but the force provided by the leg pad is the same. So the force is like before only. Okay, you know what, I have enough space over here. So force provided by the leg pad, okay, on the ball. What was the force? Minus 500, remember? Yeah. Okay, what is the initial momentum now? Final minus initial, right? Final momentum koto jani na. Okay, but what is my initial momentum? My initial momentum is 0.4 now. We divide by the time has been halved now. So before it was 0.4, now it has been 0.2 into 10 raised to minus 3. Do this in your calculator. I hope online everybody is understanding what I'm doing over here. Do this in your calculator and give me the final momentum. I'm pausing the recording. So here there was a mistake. Instead of 0.2, it has to be 2 milliseconds. I forgot that they are measured in 1-2 milliseconds. Check how much you guys are getting right now. If you do 2 milliseconds over here. How much?
Minus 0.6.
Minus 0.6. So now your new momentum here is minus 0.6. So it will stop here, na? This is 6, right? Yeah. From here the new line will start. Okay, and here this line is there. So that, and you have to join this from here till here. This is your new line. Understood? Everyone, is this clear? New diagram? Everyone else? Clear?
Yes.
Fine. And please on your cameras, eh? Okay, so I'm done with this as well. Now I'm going to find momentum questions from our question banks and do it for you all. Okay, remember momentum is a vector quantity. All of you should know that. আমরা যেভাবে vector করছি, you know, but how the vectors we did now. You're supposed to do vectors here also. I think I'm going to show you right now questions where you are supposed to do momentum vectors. Okay, I'll show them to you. Pause the recording. Okay, so this is the question we are supposed to know. This is a sample assessment paper, in short SAM. It is there in physics unit 1. It is there in the folder specification, new specification. It's in the folder new specification, okay? Or I think specification, if I remember. Okay, so yeah, sample assessment paper. Okay, these are the papers they give you before they change their syllabus, new papers and all. The two trolleys A and B are, by the way, before momentum was not there in our unit 1. It got included 2 years back. So today, two trolleys A and B are placed smooth track so that they are touching. When a peg is tapped, this is the peg on a trolley A spring inside the trolley. This is an example of an explosion. Remember, this is an example of an explosion. A spring.
Yeah.
Okay, yeah, is released.
Yes, yes.
The trolley moves apart, and the trolley is moving apart. Explain why the trolley moves apart. Okay, when the spring is released. Remember, first rule, always write to conserve the momentum. Initial momentum ki chilo? Zero. Okay, so therefore final momentum is also supposed to be 0. So both the trolleys are having momentum in equal and opposite direction. Understood? So therefore, what is the final momentum? 0 as well. Clear? Okay, so I will show you the mark scheme. Please, what is remember the page number? What is the page number? 12. Look at 12. Page number was after number. Huh? Page no. The page number is 16. Yeah. Okay, let me just pause the recording. Okay, so wait, I'll show. What was the page number?
34.
34. Okay, can you write 34 over there? It's not going to be that for sure. What I guess. 13, 12. Check karo. Answer to check karo. Answer to match one. Because I explain it in terms of momentum, because that's how it is supposed to be. As the spring is released, it extends and applies a force to trolley B. I thought it is due to the conservation of momentum. Initial momentum is zero, final momentum is supposed to be zero, but they explained here in terms of Newton's third law. Yes, and also the property of a spring. You know what happens to the spring? Spring extends, applies a force to trolley B. Due to Newton's third law, trolley B applies an equal opposite force on trolley A. But my question is that why couldn't it apply a force on A? And due to Newton's third law, it applies a trolley this force on trolley B. Whatever, just write this down. Yeah, could be. That's the thing. Sometimes the mark scheme answers and what you think does not match. I think if I would have got an examiner's report over this question, I would have known what do they actually want from me, because they did not mention explain it in terms of Newton's law or explain it in terms of momentum. Because this works with momentum also. This is an example of an explosion. Understood? Do not pour it now. Online, everyone understood meaning of this question? I'm recording, by the way. Everyone? Nobody. Kire, kyo camera on kore rakho na kire. Camera on rakho. Okay, 12 karo. 12 lekho open. Lekho 12. 12. Okay, so explain why the two trolley moves apart when the spring is released. Now, let's okay. Eta tumra korte parbe. 3 marker question. Explain which trolley will move off with a greater speed. Mass of trolley A is this. Mass of trolley B is this. Okay, you guys explain to me. Which one will move with a greater speed? Tell me that. Trolley A and a trolley B. You're saying trolley A. Why?
Less mass, more speed.
Less mass, more speed also is there, but you need to give me some more explanation. So 3 marks. 3 marks question. Please keep your camera on. I can't see any one of you over here. Keep your camera on. Thank you. You have to say both the trolley has the same momentum. Yeah, both the momentum is constant here. Both of them having the same momentum. Since the mass of A is less, the speed will be more. Understood? You have to talk about the momentum over here. You have to talk about the moment. They both have, maybe because here we are talking about the same momentum, but in opposite direction. That's the reason they did not write that here. Because then we are writing the same answer twice. Okay, maybe that is the reason they wrote this answer in terms of what? Force. Newton's third law. Okay, chalo. So here you have to write the momentum is constant for both of them. It's same, but in opposite direction. Okay, then you have to say since the mass of A is less, the velocity will be more. Okay, so page number 12 lakho again, sorry, page number 32, 30 lakho. Yes, perfect. Okay, so initial momentum is 0. Okay, our total initial momentum trolley have the equal and opposite momentum. Like a trolley A will have. We have to write that the initial momentum is 0. Total momentum is 0 actually. Have to write that.
First part again.
What I thought, maybe because you know why they explained it with the help of force, because this also can be explained in terms of momentum also. But the second question is explaining regarding momentum. Okay. That's why A level is hard. Okay, so you have to write that total initial momentum is 0. Since initial momentum is 0, both the trolley will have this thing what momentum in equal and opposite momentum. So therefore trolley A mass is less, so velocity key greater speed. Okay, red 12 here. Fine. So this is done with us. Okay, fine. Let me see whether any other questions are here or not. Okay, so this is another question. This is Jan 2019, was it? Yeah, Jan 2019 new syllabus WPH 11. 2019 WPH 11 new syllabus. Okay, WPH 1 IL, of course IL for sure. So you guys are supposed to. Can you see a vector diagram regarding P and Q has been drawn over here? But this is the momentum. Momentum is a vector quantity. So you can draw a vector diagram over here. Okay, so I'll try my best to show this. Okay, and Jara online also, if you guys would have listened to me, you guys would have had a printer right now and you could have just print it out in within 5 minutes and start doing it. Whatever. Do you guys have projector with you? Projector I think I do have a projector. What I'm going to do is I'm going to print it out for you all. Online people are going to see it from here. If you guys can take a printout, whoever can take a printout can take it printout right now itself. I'm taking printout for them. And I think I have projector lying around somewhere. And I'll see whether I can do it with you all or not. Okay. Pause recording. So everybody got the printout. I hope you guys are ready with your pen, pencil, and projector. Everyone. I hope I can see them in the. Wow, I can see everyone's camera now. Please on the camera. Everyone. Okay. So now, use the scale vector diagram to show that the magnitude of the total momentum of the sphere P and Q after the collision is about 0.2 kg meter per second. So P and Q are identical spheres. Sphere P moves along with smooth horizontal surface. Okay. The sphere P moves off with a momentum of, so P has a momentum of this much at a direction of 15 degree. And the sphere Q moves with a momentum of 0. This much in a direction of 10 degree. Okay. So these are their initial momentum. Okay. Now, what is the total momentum of both of them? Can you see they both are vector diagram? They both are what? Vector diagram. So what's the total momentum of both of them is? We have to find that. How? By drawing a vector diagram. Okay. How? Now, let's say 0.096. Now, okay. Now we have to decide a scale over here. We need to decide a scale over here. Okay. So let's decide how much centimeter should we decide? How much centimeter should we decide for 0.0? We have to make it as big as possible. Let's say 0.14 because सबसे बड़ा number कौन है? What is the biggest number over here? This one, na 0.14. Let's say for 0.14, let it be 6 centimeter. Yeah. So let's say for 0.14, I just decided this scale on my own. For 0.14, let this be what? 6 centimeter. So therefore, for 0.096, how much will it be? Try that.
0.146 centimeter.
0.146
centimeter.
0.14 centimeter. Yes, correct. Do this in your calculator. How much is the x? I'm pausing the recording. Okay, so we got for 0.14, I took it as 6. If you want, you can take it as 8 centimeter also. Depend on you. Because let's face it, এখানে কোনো কিছু নাই যেটা আমরা connect করতে পারবো. So I decided a bigger scale than 0.096 turned out to be 4.1, which is reasonable. Remember, the bigger the diagram, the more accurate your result is going to be. Okay, because the less percentage uncertainty. Less percentage uncertainty. So now check what's happening over here. Now check what is happening over here. Okay, so now what's happening? Okay, can you see your P is? Wait, check. Your P is 15 degree from the horizontal, right? So let me try it somewhere over here. Because if I do 15 degree, okay, let me draw a rough diagram for you all first. Well, let me draw a rough diagram. What I'm going to do is, I'm going to draw an imaginary line. This is my imaginary line, for example. Okay, from there, I will take what? 15 degree, na? I will take put my this thing projector and put 15 degree over here, right? So I will draw how much? 6 centimeter, not 6 centimeter, 4.1 centimeter. But I'm not going to write 4.1 centimeter. I'm going to write 0.096. Okay. Then here also I'm going to draw an imaginary line, and from here, what will happen? 10 degree, like this. Okay. Then I will join this line with this line. All of you got that? So this is how much? This is 15 degree, and this is how much? 10 degree. Clear? And I'm matching the completely with the main diagram. First of all, online everyone, rough diagram, all of you understood?
Yes.
Huh?
Yeah.
Yeah, then. Okay, fine. Fine. Let's continue. Okay, chalo then. So how will I draw now? আমি কি করব এটাকে উপরে নিয়ে যাবে আর একটু নিচে আসবে না, এটা উপরে নিয়ে যাবো প্রথমে। চলো, and if I draw a line কত 15 degree না from here, so 15, but it is giving me in inch. It is giving me in inch. Can I do I have it is given in inch, like can I do it in millimeter? 1:1 millimeter এখানে, 1:1 hand. Let's try. Now again let me try. It is still given in inch. Okay, 1:1 millimeter. Let me try again. From here, how much is it? How much? I need 6 centimeter. 60 হবে না? 6 centimeter is 60, right?
Yes.
So 60. What angle? 15 degree, na? I do 15 degree. Yeah, perfect. So this is how I took 6 centimeter as to do. It's gone. There was a way. There was a tool. Let me pause the recording. So maybe I found a way to record. Let me try. Where was it? This one, na? Okay. How much was it in millimeter? I have to find in millimeter, na? How much was it? 15?
15 degree to 4.1.
15 degree মধ্যে 4.1 আছে?
Yes.
Okay, 15 degree মধ্যে 4.1. 4.1 মানে 41. 41 কি millimeter. So here it is, right? So all I need to do is just compress this over here. So why is this centimeter coming so less over here right now? Okay, whatever, not an issue. ठीक है? Yeah. Okay. Now after that, what I'm supposed to do? I'm supposed to go 10 degree downwards, na? From here 10 degree downwards. This is 360 degree. 10 degree downwards gele kota hobe? 350 degree, right? 350 degree. Let me draw 350 degree line over here. Fine. আর এখান থেকে আমাকে কত লাগবে? 6 centimeter লাগবে, right? So let me take 6 centimeter out of here as well. From here 6 centimeter. Won't matter much. Fine. ঠিক আছে? So what I'm going to do is right now both the momentum is getting completed over here. Fine. Now what I'm going to do, join both the lines with the help of arrows together. So this is how it is. Okay, so this is the momentum. Now I need to find length of this momentum, then I need to convert it. What did they say? Use the scale, okay, to show that the total momentum is 0.2 kg. So I need to find this final, how much is the final momentum, how much millimeter, how much centimeter is it, by the way? It's around what, 98 millimeter ধরতে পারো, 98 millimeter মানে 9.8 centimeter. So যদি 0.14, you will do this, যদি 0.14 এ কত 6 সেন্টিমিটার হয় তাহলে 98 মানে কি 9.8 না?
Yes.
Yeah, 9.8 সেন্টিমিটারে কত হবে? Check how much you guys are getting. 0.23, which is close to 0.2. Everybody got this or not? This is the total momentum of your P and of your Q. These of P and Q. Clear? How much was this? 0.096. 0.096. ঠিক আছে? এভাবে লিখবে এখানে। আর এটা কত? 0.14. And you're going to delete rest of the stuffs. Online, everyone, is it clear with you all or not? I'm asking. Yalla, tell me.
Yes. Yes.
কত? 0.23 kg meter per second. So arrow is a must, angle are must, then even your scale is also a must. তোমাদের ডায়াগ্রাম ড্র করছ, এখন তোমাদের ডায়াগ্রাম গুলো সব তোমরা ড্র করো। Pause recording. Now this question was about the drawing the diagram which we showed, na? Now they said state the principle of conservation. You have any issue? Tell me. Okay, let me check what mistake he did. Check karo. Okay, so state the principle of conservation. You guys know that momentum before the collision is equal to momentum after the collision, provided there is no external force. Okay. Okay, now calculate the initial velocity of the sphere P. They want you to find the initial velocity of the sphere P. Okay, so now ওরা অন্য কিছু দিছে আমাকে, Final, I only know the final momentum. What it is, sphere P moves off, okay, to its initial direction. Sphere Q moves off with a momentum of, okay, in a direction 10 degree as shown. Okay, there are two sphere Q. Okay, now, acha, what was the this thing? When you combine both of their momentum, what is the final momentum we got? 0.23 kg, na? We got this, na? Acha, that is the final key momentum. But before the momentum, who had all the momentum? The system of shop momentum karekane chilo. Pir ka se chilo to na. That means whatever final momentum you got, that is 0.23 kg. That was the initial momentum of P also. Why? Because Q momentum was what? 0. Momentum of Q was 0. Final momentum 0.23 pi c. That means that was the initial momentum. Yes, if you believe in conservation of momentum. So what was the initial momentum? 0.23. What is the final momentum? 0.23. So initial momentum karekane chilo. P only. Okay. What is the mass of P? They gave us the mass of P. What is the velocity? We have to find. All you have to do is 0.12 into velocity equals to 0.23. And V is equal to 0.23 divided by 0.12. Everybody clear with this concept? Here, most of the students get confused by they didn't give us anything. But you know the final momentum after the collision with the help of vector diagram. What is it? 0.23. That final momentum was the initial momentum. If you know your momentum properly, you have to understand this. That's why Bahading doesn't work in this one. You have to understand how does a momentum work. Momentum before the collision should be equal to momentum after the collision. Fine. Okay. Chalo. Let's go to the next one now. Let's go to the question number. Oh, we don't have to do this. I'll pause the recording. Let me find another sum for you. A ball traveling horizontally at a speed of 7 meters per second. Okay. Ball hits the vertical wall. So this is the 7 meters per second. Okay, vertical wall and rebounds along the initial path. So ball ta rebound korte say at 5 meters per second. ठीक है? Okay. So it a -5 हो जाएगा because direction change हो गया. The ball has an acceleration of so and so. So which of the following expression gives the time of contact t between the ball and the wall? Time. They want time. You know, time is. तुम्हें जाना force into time is mv minus u. You guys know this, na? Yeah. Or a mass task কিছু দিছে এখানে? Ballটার mass কিছু দিছে? আচ্ছা. Do you also know force means mass into acceleration into t is equal to mv minus u? জানো এটা তোমরা? Mass and mass gets what? Cancelled. Acceleration you know, final velocity you know, initial velocity you know. Time find karo and check which one matches the answer. You see কিভাবে ঘুরে দিছে কোশ্চেনটাকে? But v is equal to u plus at দিয়ে করা যাবে কিনা? But ওটা টাইম ইন কন্টাক্টের কথা বলতেছি এখানে। Actually ওটা দিয়েও হয়ে যাবে। ওটা দিয়েও হয়ে যাবে। Yes, ওটা দিয়ে হয়ে যাবে। But আমি এখানে তোমাকে মোমেন্টাম দিয়ে প্রুফ করছি এটা। Time in contact because whenever they say time in contact মানে কি? কতক্ষণ টাইম ছিল কন্টাক্টে? Okay, but and your sign also matters over here. তোমার sign matter করে এখানে। দেখো তোমার acceleration কত? 300. Ball has an acceleration 300 while in contact with the wall. Acceleration টা কোন দিকে হবে? লেফটের দিকে হবে না? তোমার acceleration নেগেটিভ করে দাও তুমি। Acceleration কে নেগেটিভ করে দাও into t তারপর ফাইনাল ভেলোসিটি কত -5 আর ইনিশিয়াল ভেলোসিটি 7 ঠিক আছে সো t is equal to -5 -7 divided by minus কি 300 so which one matches over here b no a matches question number 6 let me check the mark scheme of this you see this is the reason we need momentum here তুমি v minus u by t দিয়ে তুমি acceleration কে নেগেটিভ নিবে না because you need to take direction into key consideration. Which question number is it? Question number 6. 4, 5, 6. A is the correct answer. All of you and everyone. Is this clear? The whole solution here. Is it clear? Online Jarasa? You saw? 1 mark. And you should not wait more than 1 minute over here. Okay, so, egg mark rate. Yes, okay, done that. And you have to be very creative in your A levels, guys. Very creative actually. Let me check whether is there any other momentum related questions over here. Okay. This question I still could not solve. I need to sit today. Maximum height. This has a bit of momentum in it, if I'm not wrong. I think this had a bit of momentum in it. I don't remember it though. I can give you guys this guys as a homework. Okay, chalo one thing, guys. Do one thing. It is June. What is it? Jan 2000?
Jan 20.
No, October was it?
Jan.
Jan 20. Okay. Go to you write Jan 2020 Physics Unit 1 question number 16. Jan 2020 Physics Unit 1 question number 16. You guys will do this on your own. 16. You guys will try to do this on your own. I have a feeling this is a momentum related question. Okay. So let me check other also. Pause the recording. This is October 2020, October 2020, Unit 1. Okay, WPH, PH11. Fine. So start doing this on your own and see whether you can do this. Pause recording. এটা হচ্ছে momentum before the collision. Momentum after the collision হচ্ছে mallet is going at 0.3 into 0.17 plus disk এর velocity কত জানি না কিন্তু mass হচ্ছে কত 0.035 into v. Okay, so if you bring this over here, minus করে যদি তুমি 0.035 দিয়ে divide করো, your answer should be around what? How much was it? 6.3 meter per second. ঠিক আছে? Fine. They're almost at the brink. Okay, this one. Now, should I do this with you right now or not? Because this is slope related. Okay, I'm not doing this. Okay, you know what? You know what? October, write down October 2020. Yes, October 2020, Unit 1, question number 18, homework. Unit 1, question number 18, homework, new syllabus. Okay, WPH11. So I'm ending the today momentum class is completely what? Done. Over. Done. Tata everyone.